Welcome, everyone. Thanks for coming. We're going to go ahead and get started on chapter one, section one, which are linear equations. And we have a few definitions before we get started on the math. A linear equation in one variable, we'll call the variable x. An equation that can be written in the standard form ax plus b equals c, where a and b and c are real numbers, and a can't be zero, otherwise we don't have an equation to solve. Solution set is the set of numbers which, when substituted for the variable, make a true statement. And we'll see examples of that in just a moment. When you are asked to solve, always give the solution set. An equation is conditional if it is true for only some or none of the real numbers in the domain of the variable. An equation is identity if it is true for all real numbers, and we have an example of that coming up in just a moment. There are three types of possible solutions. We have a unique solution. This is specifically with linear equations. This is the norm. Usually we get one answer. Empty set or no solution is sometimes referred to as the null set. And occasionally you'll have an online homework system that wants you to put DNE for does not exist. And here are different ways you can do that. This is the empty set symbol or the null set symbol. No solution, X is empty. The third one is all real numbers. Now, these last two are unusual cases. This more often than not doesn't happen. And any rational equation, all that means is that there's a fraction involved. So let's do an example. So part A. Whenever I have fractions in my equation, I want to get rid of them sooner rather than later. So I'm going to notice between all these denominators that 6 is a common denominator. When I multiply this times 6, 6 divided by 2 is 3. 3 times 3 is 9x. For here, 6 divided by 3 is 2. 2 times 5 is 10. Here, the 6's just completely drop out. We end up with 5x. Now here, a common mistake. You may think that you want to take the 6 and multiply it times 1/3 and the 2x and the -5. That's not true. This 6 is only going to be affected here. If you distribute it inside as well, that means you've multiplied this whole thing by 6 2 times. By 3 is just the 2. Apply the distributive property here. Combine my like terms. Now what I'm going to do is subtract 9x to both sides. In this case, all x's disappear in this case. What this tells us is that the answer is all real numbers. One way to write this would be here, with this weird looking R. This symbol here, if you haven't seen it before, sort of a C with an extra E tongue in there. It stands for an element of the real numbers. In an interval notation, it would look like this. Meaning you can take any value for x you want, and if you put it in there, there, and there, the left side will always equal the right side for all circumstances. Part B. All right. Now in this case, our common denominator, it looks like it's going to be 12x. So I'm going to multiply both sides by 12x. And for this first one, 12x divided by just 4, so this becomes 5 times 4. Here, 12x divided by 4x is just 3, so this is 7 times 3. And here, the 12 and the 6 reduced to a 2, so this becomes 5 times 2x. So let's clean this up a little. We got 20 minus 21 equals 10x. Negative 1 equals 10x. Divide both sides by 10. Tells us that x is equal to negative 1/10. So this one has one unique solution. We talked about this up here. Let's put that down a little bit. One unique solution, that's here, negative 1/10. And here we have this one, all real numbers. See it there. All right, let's move on to page 2. So we have a few more. Now, when we have formulas, meaning there's more than one letter or variable in there, we can't use set notation to do that. So let's start with part A. 4 over x plus 1 minus 3 over x minus 1 equals negative 6. Now, I'm going to go ahead and factor that. Difference of squares, x minus 1, x plus 1. And I can see right away that the LCD in this case is x minus 1, x plus 1. And those are being multiplied. I just wrote them on top of each other to save some space here. When I multiply both of those to here, the x plus 1s reduce. I'm just left with 4 times x minus 1 minus 3. And you'll notice here the x minus 1s reduce. I'm left with 3 times x plus 1. And here the x minus 1, x plus 1 completely reduced with that denominator. I'm just left with a 6. Be careful here. We're going to be distributing a negative 3. Combining up my like terms, 4x minus 3x is just 1x or x. Negative 4 minus 3 is minus 7. I'm going to add a 7 to both sides to get x 1. However, we have a problem. When x equals 1, do you see when I plug that into here, 1 minus 1? I get a 0 in the denominator. So in reality, this can't work. So this is the case where there's no solution. So we can do the circle with the line through it, the null set or the empty set, or we could just write or no solution. All right, part B. Okay, I'm going to go ahead and distribute that 2 first. And then I'm going to multiply through by the LCD, which in this case is 5. And that will knock out that 5 there. So we just have 3x minus 5ax equals, the 5's reduce here. I'm just left with 4x. 5 times negative 2 is negative 10. So I'm going to gather the x terms to the other side, to the left side in this case. You notice I have 3 terms with x's in them. These two can't combine because of the a. So we have negative x minus 5ax equals negative 10. I'm also going to notice that now I can factor out an x, -1 minus 5a equals -10. And now I can divide out -1 minus 5a. X equals -10 over -1 minus 5a. And if I multiply the top and bottom both by a -1, x is just 10 over 1 plus 5a. No problem. Let's do C. Minus 2 times x minus 2b equals ax plus 3. All right, now this one is very tempting. You see that 4 minus 2 and you want to combine those up. I can't do that, unfortunately. I am going to distribute that -2 into the parentheses. And I can't combine any terms. However, what I'm going to do is I'm going to get my x terms to the left. Minus ax, minus ax. And I'm going to move my non-x terms to the right. That'll be -4, minus 4b, -4, minus 4b. We're going to end up on this side, -ax minus 2x equals, and on this side, we are going to end up with 3 minus 4 is -1, minus 4b. And up on the left side, I'm going to factor out an x. So I have -a minus 2 equals -1 minus 4b. I'm going to divide out -a minus 2, minus 2. So I get x equals -1 minus 4b over -a minus 2. Like with this one over here, I don't like all those negatives, so I'm going to multiply the top and bottom by -1 to give me this. And the order doesn't matter. You could have the 4b first. Now we have an application. Three, a total of $51,000 is to be invested, some in bonds and some in certificates of deposit, CDs. If the amount invested in bonds is to exceed that in CDs by $3,000, how much will be invested in each type of investment? So I'm going to let X equal the amount into CDs, certificates of deposit. Now we know that the bonds have to be at least 3,000 more. So X plus 3,000 is going to be the amount into bonds. Well, if I take the amount invested into the CDs and add it to the amount invested in the bonds, it should equal a total of $51,000, and then we'll have an equation to solve. So X plus 3,000 equals 51,000. A common mistake on these is students won't put that first X. They'll just put X plus 3,000 equals 51,000. There are two. So this is the amount in CDs. We could even partition off of parentheses like this to really emphasize that this is the amount in CDs plus the amount in bonds is going to equal 51,000. So I'm going to combine it by like terms. So 2x equals, say that'll be 48,000 divided by 2. And you could use the calculator, but I know half of 48 is 24. So this would be 24,000. This is into CDs. I know that because I defined X as being the amount into a CD. Now, that means that it's going to be for the bond, it's going to be $24,000 plus the 3,000. So that'll be $27,000 invested in the bonds. So here are my two solutions. Not so bad. Make sure you take your time with the word problems and make sure that you clearly define what your X and Y's, or your X's are, and if there is another Y or something, you'll have to define that as well.